So we're now on the hour. The session was supposed to end around here, but let's perhaps use a little bit of the break for a mini panel in case anyone has any questions to the authors of the 3 papers in the session. Please go ahead. It seems like that Lei Shu has a question. Lei?
I do have a panelite question. So what is the next technical trend that you will be seeing that would affect serverless platform in the near future? I've seen people talking about disaggregated architectures, and I've seen people talking about heterogeneous hardware. What is your thought?
It's a very generic question. Any of our speakers can pick it up. Any volunteers? Shipong, what do you think? And I know that Shiming is not exactly working on serverless, but maybe you have any thoughts about the topic as well. Nope, Yinchi?
I mean, yeah, I think there like some of the challenges that I might be seeing is that like servers might not have the good abstraction for logging or for like doing caching and this kind of things, and like even if like their system designing for this, they really require some like dedicated resources, dedicated DBs, or some key stores to keep the data or keep the metadata generating execution. And if you have, we can also make the storage layer as elastic and as serverless as the computation part itself. That might be an interesting angle to look at. And that's my personal opinion. Yeah, it's generally a very big question.
Yeah, it's a very good and very broad question. I think also that it's we need to understand in which points are we still not have we still not reached the vision of something where the user doesn't have to worry at all about porting applications and managing resources when porting those applications to the cloud. I think the programming aspect is something that might be also still open. Do you guys agree?
Yeah, there are some work like also products on like AWS step functions or turbo functions, but still, as you mentioned, they might lack some of the expressibility to write programs as flexible as on like on a VM. You can control everything. Mm-hmm. Yeah, and also it's also like from the Harvest perspective, it's also interesting to look at how to support like that kind of computation on this Harvest. Yeah.
Thank you.
So thank you for the question. I think I have a question from Somali. Let me promote Somali Chatterjee to as a panelist so that he can pose the question. She can pose the question. Sorry.
Hi. So my question is about, I'm Shumali, by the way. Very nice talking. This was for the last speaker on Harvest VMs. So my question is regarding frequently invoked functions. So have you observed functions that are frequently invoked? And based on these invocation patterns, can you learn whether to run these on Harvest, Spot, or dedicated VMs?
So you're asking like if there's any specific pattern for these frequently invoked functions?
Yeah, so have you seen the invocation patterns? And based on learning some of these invocation patterns, do you think, this is a slightly more general question, based on these invocation patterns, have you seen that there are certain kinds of functions that are more suitable for Harvest VMs versus Spot VMs versus dedicated instances?
So the workload we are looking at is a function as a service workload, which usually has a maximum time limit on their durations. So,
correct.
So
but even for those, you have invocation patterns, right? So for various kinds of functions in these workloads, you might see different invocation patterns. So have you seen the suitability of these functions for various kinds of instances?
Yeah, could you, so I don't know if I quite get your question. So what do you mean by the kind of the function? What kind of type do you specifically refer to?
Yeah, like I was just wondering, have you done like kind of a case study seeing the invocation patterns of these functions, right? So these are serverless functions. And then based on that, you might have seen that, these are more suitable for various kinds of VMs. So Harvest VMs is slightly new to me. The more frequently heard kinds of VMs are like the Spot instances and dedicated. So I'm wondering, have you seen some kind of suitability? So say, for example, some function is invoked every 1 second, another function is invoked every 10 seconds. So say the frequency of the invocation, for example. So based on that, different suitability trends. For
I see what you mean. So the problem, like for the stability of invocation or function of Harvest VM, is mostly related to their runtime, their running time, which is duration, and I think as long as a function or invocation is short, they should be safe to run on Harvest VMs. So in that case, like invocation patterns or interrupt time might not play a very important role if you just talk about the feasibility on Harvest VMs. But interrupt time might play a role, like in the pre-warm, in the container pre-warm, all the other techniques that you use to reduce cold starts. Yeah.
Got it.
Cool. Thank you so much.
Job.
Thank you. We're ending the session here. Thank you. Thank everyone for listening and participating. We have a 5-minute coffee break in an espresso machine near you, and make sure to come back for the next session in 5 minutes. Thank you.
All right. So if now we have time to run a mini panel. So can I invite the authors for the first 2 papers back as well? I think you should all be around. So please turn on your video. Yeah, thank you. So we have time for open discussion. So I think the interesting part here is that serverless seems to have been around, and there's actually a lot of interest in there. But I think also in the morning, there are also questions that, what's the trend for serverless? And also, for example, there are ideas from papers from time to time. To what extent are they adopted, or do you see adoption in different ways? I guess especially you guys may have perspectives from either academia or industry or particular workloads. So I don't know if anyone has any comments on that.
Yeah, I can start with talking about the situation at Meta. Actually, the biggest reason that the company was able to move super fast, deliver so many products, and in my opinion, the biggest magic sauce is serverless. Besides Blade Runner that we built, which is more optimized for long-running streams, there are actually 2 large platforms. One allowing people to write hack, which is essentially PHP. The other Python. Those are the 2 places where product developers will just write codes, land it, and then see it work in production after a few hours. It really boosted the productivity of product development compared to other companies I worked at, where a product developer needs to maintain their own microservice, figure out capacity. It will take a lot of their time to figure that out.
I see. So it's basically saying that essentially Meta have been using the APIs to just roll out applications very quickly.
Yeah, exactly.
Cool.
I have a follow-up question, and this kind of ties to two talks in the session, which basically were about introducing a bit of state into serverless frameworks. So do you think that will drive more adoption of these kind of serverless frameworks? Is the missing piece in today's serverless frameworks that they're not stateful enough?
I mean, the more state part of the serverless, stateful parts.
Sorry, I missed that.
You mean the stateful serverless? You mean it's a
yeah. So enabling statefulness in serverless, do you think that will drive the adoption of such services more in the future?
Yeah, I'm not in the industry, but I'm very interested also in this question, whether stateful parts is actually one major problem preventing to more workloads applications in some sense. Actually, Balki's research is mostly motivated by these thoughts, like, I guess, using log is especially for the consistency for tolerant consensus is a massive problem for every distributed application. And it seems that Dallas already have the conclusion that the log is what we want. So bring it here.
So I have a question that's partly follow-up, partly different. So especially for the bulky paper, right? So I mean, there was also some comments. So share log has been used quite a bit, and then of course you've adapted it to serverless, right? But then one of the main things for serverless is kind of elasticity, right? So then in the bulky paper, it seems to me like the main aspect was in this separating, optimizing read and write aspect. So are there other aspects of elasticity or locality or similar things that might show up, or I mean, I guess the question is, do you think that's sufficient, or are there other aspects of elasticity issues that may show up?
Yeah, elasticity is one important aspect in serverless. And when I do this study, I may not do that many evaluation on these parts because of the limited results. But in my mind, from design perspective, I think internal design of Metalog actually making different components being very modular. That means you can scale in different dimensions. You can add more storage nodes, maybe for more capacity on the storage. You can add more cache, so you have better read scalability. You can add more like this sequencer. You can have many parallel physical logs, so can scale in this dimension. This is the beauty of this design in general. Although I don't know, either it works in extreme scale. This is the thing I really want to dig, probably.
So I have one more question for the Yanshi's paper. So I think you talked about harvested VMs for supporting serverless functions. Do you see moving ahead in the future, like there might be usage of more heterogeneous resources and heterogeneous VMs of that type for hosting serverless functions as well? And I mean, like GPUs and there's like a lot of interesting, increasing heterogeneous resources popping up.
Yeah, I think that's an interesting question, and definitely, like, if we can have servers run different kinds of devices and provide users a simple like API or programming interface, and we can support more devices like cloud GPUs, cloud FPGAs, and these kind of things, and we can have more more design space options for the users to have like to tailor like their workloads. And it's also interesting, like if you want to keep the interface server as simple as possible, like just writing one kind of code without like tailoring for different kinds of devices or languages and having the cloud providers picking the kind of devices on the back end. And I think that might be an interesting problem.
Right. The other part of this question is basically, do you think there's enough harvestable heterogeneous resources in the cloud for us to use for serverless frameworks?
Yeah, I think in some previous profiling of the internal data centers of large cloud vendors like Google or Alibaba, I think most of their CPU usage and memory usage are well below 50% most of the time. And I think you can imagine an even lower number for this kind of public cloud providers instead of internal clusters. So I think there's a big room for harvesting.
So I have a separate question, but maybe related as well. So the thing about harvesting VM or whatever, basically you need to somehow figure out their spare resource and stuff, right? So I'm actually very curious to what extent or to any extent if there's any predictability in the resource pattern. So for example, now again, I'm mixing up different measurement papers I've read, right? So for example, maybe it's internal production traces from Azure. I'm pretty sure there were a lot of recurring jobs actually either from Azure, maybe was it from Google, I forget. So now I don't know whether anything like that may happen to like public cloud either as well, because it depends on what kind of customers you might have, right? So do you happen to know anything about that?
So yeah, I cannot speak for Azure like what their like customers workloads should look like, but I think so from our perspective for running servers and workloads, the first thing is that if your data center is really like saturated with this kind of recurring high priority jobs, so in that time you might want to like stop harvesting and step back to some dedicated resources if that case really happens. And the second thing is that since the public cloud providers usually have a very large cluster that are geographically distributed on different parts of the world, so that sort of like evens out the different peaks or different surges in the load, and probably you can find a good place to put your serverless workloads at the time you want.
But then if they are geographically far apart, because sometimes you also want the VMs to be somewhat close by, right?
Yeah.
Or maybe that's also another consideration. So yeah, I don't know how that will be factored into the consideration.
Yeah, in that case, I think so it also comes back to the previous question that I think data centers are mostly underutilized, and this case is unlikely. It's not very likely to happen. And in that case, if it happens, you probably need to stop harvesting.
All right. So okay, we're actually rough at a time. If there are no questions, we can just leave like this, or we can, if any of you want to ask each other questions or make comments, feel free to do that as well. Or maybe you just want to go home. All right, then. Okay, so I guess in that case, let's leave it for this session. So thank you all very much for the questions and comments. And then I guess the next, we have actually almost 15 minutes break until the next, I think it's Smanik or something. And then, I mean, unfortunately, the coffee break or whatever break, depending on the time, is not sponsored by anyone. So maybe just ask your advisor or your employer for sponsorship. Okay, thank you so much.